Hello and welcome to Unprofessional Engineering Part 2 from Accelerate 2018. My name is James.
And you got Luke.
And Luke, now we are joined with Vincent. I can't even say your last name right. How do I say it?
It's Wegener.
Wegener.
Let's keep it to Vincent.
Okay, Vincent.
Exactly how I would pronounce it.
Right. From RAMLAB. So before we get into RAMLAB, what it is, what you do, all of that sort of stuff, we have a couple questions that we're designer, engineer, or scientist. Who would it be? Living, dead, any of them will do.
Yeah, right. I'm not going to say Elon Musk because everybody says Elon Musk.
He's an easy one.
So, he's who I'd probably say.
I think scientist is actually this Professor Brian Cox. Perhaps you heard of him from the UK.
Okay.
And he does all these documentaries about the stars and the universe and.
Yeah, he's like the UK version of Neil deGrasse Tyson.
Right. I think so.
Exactly.
Okay.
Exactly. That one. And he explains it so well, and you feel so tiny after seeing some documentary. Like the universe is so big, and then you're basically a speck of dust, right?
Fair enough.
So it's always that's always good to get both feet on the ground again.
I like it.
Feel small.
I like it. Okay, so if you weren't doing this job, what would you do? Dream job. And I know you love this job and it's amazing and all. Yeah. What would you be doing?
Yeah. Well, actually, I'm an entrepreneur, so I created my own job, and I'm actually very pleased with my own job that I created. So sorry for that.
Easy enough.
But really, who wouldn't want to be working with the machines we have, the robotics and printing stuff and printing propellers, doing new stuff.
It is a pretty cool gig. So
yeah.
I guess we can't complain.
All right. Can I
we'll
be
let
pleased
you
with
do
my
it.
own job?
Yeah.
Is that okay?
And interesting, you were talking about the stars and the planets. Do you think Pluto is a planet? Or do you agree that Pluto is not a planet?
Does anybody really care?
What?
Yeah, there are these movements, right?
So so the reason why I grew up, I'm of that age where Pluto is a planet when I was a kid.
Same
and then
here.
Neil deGrasse Tyson, he's the reason why Pluto isn't a planet anymore. He had a whole campaign to make it not a planet.
He spoils more parties than
he
anybody.
does. He does, doesn't he? So
that's beautiful.
So you believe Pluto is not a planet, like current thinking?
Yeah, but does Pluto really care? It's
Yeah,
just being there. Yeah. No.
Fair enough. Last but not least, rank these in order: Harry Potter, Game of Thrones, Doctor Who, and Star Wars.
Oh, I'm a huge Game of Thrones fan, so
finally.
Okay,
The
you really
rest-
had to answer that question. Now we'll be friends.
That's really what we wanted you to say. Okay,
Right.
perfect.
We're all waiting for the next season, right? So
So long.
yeah,
So
the
long.
wait is killing.
So moving on to a little bit more about RAMLAB and everything else that you're doing, I guess tell us a little bit about what RAMLAB is.
RAMLAB stands for Rotterdam Additive Manufacturing Lab.
Obviously,
yes. And what we do is we are currently researching as a lab on the topic of large-scale additive manufacturing, specifically metal parts. We do that together with many partners such as Autodesk, but also local companies who help us out. And we have one common ground: is that we're interested in can we make large parts and can we make it better than is done traditionally, like casting or forging, and can we make it better and faster?
Okay,
so that's what we do.
Very good. So how did RAMLAB get started? So I understand that there was it's relatively new, and it was out of this initiative that kind of came up that you were involved in.
Right. So how long do we have? Because it's
Hey,
you want the long version or
long
the
as you
short
want.
version?
Can we go medium?
Let's do the medium version.
The medium version. All right. So I founded a makerspace, RD Makerspace, 5 years ago, together with a friend of mine. And from that, we always had the dream, like, what can 3D printing mean for more the port-related sector?
Okay.
Not only for the consumables. Back then, it was like the Ultimakers of this world.
Gotcha.
But there is a large potential, of course, also for more conservative industries. So with a local fund, we looked into what parts we could actually print. And there were like 20 to 30 partners involved from the port-related sector. And we actually printed parts with different different machines to show the potential. And from that, the Port of Rotterdam joined our initiative, and they said, well, what are you going to do after this pilot project? And we said, well, we would like to have a lab, if possible, a permanent place where we could do this. And they said, well, this is in line with our strategy. We want to become the smartest port. We are going to invest in this lab because we think that it can have this technology can have impact on the future of the port, right? If you're going to make parts locally, what will happen to the port, the function of the port?
Okay.
If we're not going to ship the parts anymore across the world. So that was the starting point, actually. And in 2016, they agreed to fund the lab. And from then on, I was appointed to set up the lab and get started on it. So,
I guess following up on you being appointed to set up the lab and run it, then what's your role there?
So you have to imagine a space. We're in a big machine, former dockyard, but it's completely renovated. You can imagine an empty space, and it has to be filled with machines, and people have to be on that machine, and people have to be trained, and we have to have partners that tell us what to make. So basically, from all these partners, I had to convince them to join us. To recruiting the PhDs and postdocs to do the work, to involve Autodesk and other partners to help us out with designing parts. Basically setting up the lab. That's what it entails. And then the first project we did was the propeller, the big part. So that's because Dama Shipyards, they joined as a partner. And we said, what would you like to print? And they said, propeller was the obvious.
I was
choice.
wondering why because the propeller seems like a very difficult one to start with. I would think, let's print a box first, right? To make it easy. So they were the ones that requested to be a propeller as the first thing to work on.
So Pomaren is a company that designs and they supply Dama with propellers.
Okay.
And they came to us and said, well, wouldn't it be nice to repair blades this way, right? You just have a propeller, and then when it's cut off or whatever, you weld on top of it, and you repair your propeller. That's how it started. And then we said, okay, let's do it a bit more ambitious. Let's reach for the stars, right? And see if we can actually print a propeller. If you can do that, then probably we can also repair it. And then, Dama was also interested in the potential of the technology. So everybody said, let's first print a propeller, and then if we can do that, we'll look into repair later.
And when you say print, I've seen the video.
Right.
And this isn't like 3D printing the way I think of 3D printing. So this is basically like welding in midair or something along those lines, right? Could you explain that process and what it's called for those that don't know the process?
Yeah, so the only thing we're calling it 3D printing is because of the layer on layer stacking of layers, right? That's why.
But that's the only thing it shares with 3D printing. It's totally different other than that.
Yeah, it's a big family name, right? Family group of you have powder, you have FDM, you have plastics, powder, you have metals, you have. So we're in the metal field, and then we weld with wire, so we don't do powders. We just have a normal welding robot, and if you have the right software, you can make actually 3D parts with them by welding 3D layer on layer on top of each other, right? And that's how you create a 3D shape. So the official name for the technology is wire arc additive manufacturing.
Okay.
But it's a long name, so we say 3D printing.
And is it typically one robot, multiple robots? How does it typically work?
Currently, we use one robot to make one project.
Okay.
For the R&D project, it's for the environment we're in, it's more than enough. But if you want to go to production of very heavy, very large-scale parts, then probably you should look into adding more robots to the same workpiece. That could be very interesting because then you can increase the kilos an hour.
Okay.
And then you have your part faster. So, but that would also increase complexity.
And that's one of the limiting factors because how long did the propeller take? What was it? A week or 10 days?
10 days.
10 days,
yeah.
right.
Yeah. But that's the difference, I think, between like an R&D environment we're in right now and towards the production environment we want to go. You have to make some iterations on the propeller a few more times, and you can probably go down to 7 days.
Okay.
Still, that's a lot faster than casting it. So when you cast a propeller, you have to do it somewhere in China. It takes about 6 months to get your propeller. So
Oh, wow.
Sounds like a good time savings.
If you need it if time is the price you pay and you want to pay for that to have it faster, then this is a viable option.
So you had to get this to be, I guess in November, you unveiled it to be the first class-approved 3D printed propeller, right?
Right.
So I guess 2 questions. What does that mean? Like, what does it take to become approved to be used? As well as, how long did the whole process take? Was that like a 2-year process then? And then the final print was the 10 days that you think you can get down to about 7?
So the start of the project was May 2017.
Oh, so a lot faster then.
A lot faster.
Okay.
So we before that we had a little bit about the discussion of repairing or making a propeller, and then in May we said, okay, we're going to make a propeller, and we're going to involve class from the very start, so they can look in our process, and if it's not going to work, and if they're not approved of our process, then we're not going to use it on the ship. But at least we have the shape, and we can show the progress we made. Of course, we were just starting, so we said, like, let's make something that makes an impact, show that we can do it, prove it to our partners, prove it to the outside world that we can actually make something. And then along the way, we showed that we have the material knowledge, that we could replicate how we weld our parts, that we can show with reports, with data, that we are sticking within those parameters that are required. It's building up of knowledge and sharing that knowledge with the class bureaus that convince them that we have a very high quality part.
So the parameters fall into like size and material strength. Do you have to like stress test the parts then? Things like that?
Yeah, so the way a casted propeller is tested, you have a batch, you cast the propellers, and next to that in the same batch you cast a block. And basically from that block you take the samples to test tensile strength, stuff like that. And we, of course, we cannot do that we have to do it serial. So first make a block, and then with the parameters stored from the robot, weld exactly the same with exactly the same parameters we weld the propeller. So and that way we could prove, like, okay, we have control over our properties. We know what we are doing. Now the interesting thing is, of course, if we would make another propeller the same way, would we need to make the whole wall, the block again, or is it good enough to use the same parameters and show? And hopefully that's the case. But it's also a learning experience for class bureaus, right? So it's a new technology. They have all these big books and on guidelines on how to make parts, and they're all traditional ways. So casting, forging, welding, but 3D printing is new. So for them, it's also a new manufacturing method, and they have to explore, see how they can handle it.
You mentioned the manufacturing method. One thing I noticed in the video that we watched was there still seemed to be a lot of manual process involved. So after the robot is done doing the welding, then there's a lot of, it looked like hand grinding.
Yeah, it was hand grinding.
Is the plan to maybe get away from hand grinding and maybe do some 5-axis CNC to then do that finish pass to create that final part?
Yeah. So actually, we made a prototype the same size, a bit more heavy, by the way. So that was our first trial of, can we make this big part? And that, as a test case, we sent it to Autodesk Birmingham, and they milled one blade for us.
Okay.
Just to show that it can be done. We wanted to finish the project within a year of opening the lab. End of November, we were 1 year old. So it was decided to grind it.
Okay.
It was it's also the normal way of grinding a propeller that comes back from the casting company. There's always a finish by Promarin. It's always done by hand. Of course, we're looking into robotic grinding, for instance, but there are also some challenges with that. Just by hand, you can feel if you're on the right track.
Yeah.
And a robot is very difficult to have that adaptive system. So we're looking into it, but and also it's part specific if you need to do grinding or not. But the only way it will work, I think, in the future is if we automate that process.
Okay.
Yeah.
So I can understand you being interested in this and why you're leading this charge. But what about the shipyards you're working with? So the Damon shipyards,
Yep.
right? What about this made them think it's a good idea? I know you said that they wanted to be, what was it, a smart shipyard, or they wanted to be top in class leading this. Why?
Yeah, for Dama Shipyards, this is more also from an R&D perspective, is to learn about the new ways of making things, and the best way to learn from new technologies is to be actively involved, right? Not to see it from a PowerPoint, but just do it, and then learn and see if it's something you can adopt. Now the propeller is a case for them also to show that it can be done. But we went through their whole ship, and then other parts come up like, hey, perhaps we can optimize this part. And during my presentation, I actually mentioned one part is the part of the hull, which is a very heavy part, but it can basically be a shell. So the reduction can be in weight can go from 60 to 6 kilos. And we did trial for them, and probably we're going to install it next year with them. So those parts can only come up when you do a big project like the propeller, right? Then people start to think about it. Then the engineers start to think about it. Then management embraces it. And if we would have started with a small, non-sexy part, say, then we wouldn't have the support from the.
So starting with the impeller was a really good idea then.
The propeller, yeah. So
propeller.
So for many reasons, it was a good case, for just to show that it can be done and to start. It's a real conversation starter. Yeah.
Okay.
So moving on, you're now working on or finished up a giant 3D printed steel crane hook. Is that about right? Is this project still underway, or did you just wrap it up?
My team in Rotterdam is working very hard to finalize this project. We are around 1 week in the project right now. And this is a 4-prong hook, and it will take about, I think, 2 more weeks to make it.
2 more weeks. So it's not in the printing process yet?
It is
or
in the process.
Is
yes.
the print
Actually
done and
printing
you're
right
finishing the grinding or something on it?
We did some grinding today, but we are still in the process of welding.
Oh, okay.
So what we do is we have to do some grinding for class bureaus to show that we have, that it's homogeneous material. So we're going to do some NDT testing right now. But we did about 200 kilos, and we're going up to 600. So the total piece is 800 kilos.
Wow.
Hook. Yeah.
And the heaviest 3D printed hook ever.
Yeah, I think the only 3D printed hook. But it's and therefore the heaviest. But yeah.
But the big advantage is that it's actually hollow, right? Or that's one of the big advantages.
Yeah. So something you cannot do with casting, or very hard to do with casting,
right,
is make a hollow parts. And for us, it saves time, of course, but it's also better for the properties because you bring in less heat, and therefore, it's better for the material properties.
And not a lattice structure either inside. Like we would think from desktop 3D printing, that it's always like that honeycomb look. That's not what it is. It's just completely hollow.
Yeah, just
inside.
hollow. And we've looked into honeycomb, but then you get the issue because it's always near shape, and when you weld bead on top of each other, there's always some, it's the surface is not smooth, so there's a potential crack point. And if you cannot reach it to grind it, then you have that risk, and then class will never approve it. So that's why it's hollow, so we can still reach in that section with a tool and grind it a bit. Yeah.
Okay.
So I think there's this perception that 3D printing and this newer technology is somehow inferior to casting and some of the traditional methods. And just wondering what your thoughts are on how we change those perceptions and what the next step is to make the kinds of things we're doing and we're talking about right now more mainstream and typical.
All right, so I think everybody who is involved with casting knows there are a lot of problems with casting. So there are, one of the biggest problems is porosities, and the other thing is that the casting companies used to be in the Netherlands as well, and then they moved out to the more, to lower labor countries.
Mm-hmm.
Actually, one of the class bureaus has the joke is, the running gag is like, how do you recognize, or how do you know where a ship has sunk? well, the propeller will float up because of all the porosities in the propeller. So what happens often is on the outside it looks fine, but if you cut it open,
Right.
you know, if you
It's
don't
really
do
bad.
casting properly, you have these gas pores and stuff like that. So it is actually a problem. And the hook is a good example of that as well. They try to cast the hook 5 times in a forgery or a casting company in Italy, and the 5th time it worked. And every time, you know, they try, it takes about 9 months to cast it, to cool it, to grind it, and then
Wow.
you have these. It has to be approved, and the big problem is the bigger you cast, the more problems you have with the cooling. So the outside cools faster than the inside, and you get these tensions and stresses, and then it just rips apart the part,
Right.
literally. So that's why this company Huisman is really interested in this technology, because you have better control over the process, better quality, one time right. So in that sense, it's there's a lot of potential for this technology. And what we've shown with the tensile strength we did, and is we have better properties, we have better tensile strength than sand casted parts.
So I'm thinking about the people, like when you're printing this, there must be people standing around watching to make sure everything's going okay, right? And all I can imagine is the old steel mills and people like just like next to these fires. How do these people stay safe? What are they wearing? Are they just hanging out far enough away that it's okay?
Yeah, so of course the robot cell has some safety, like these lines. You know, when you cross them, the system goes off. And I think it's the technology. It's a lot cleaner than casting and forging. If you've ever been there, you know, it's a lot of dust, heat. There's a reason why it's no longer done in Europe, Western Europe.
Right.
You know, it's moving towards parts where the environment laws are less strict. And welding is a very clean process. It uses electricity, you know, to create the spark. In that sense, I think it's if we can go to a world where we make one, where you need one, then you can go back to local production. As far as safety, yeah, of course, you're working with parts that are hot, and so you have to wear clothes and stuff like that. But it's nothing special in that sense.
So if you think about like other industries, like where you could see this going, obviously you're been focused on shipyards and specifically with shipping. I think that there's so many other industries that this kind of technology could affect. Is there, if you had to look in your crystal ball, like what would be the next big thing? Is it something like automotive, or like what's that next big thing with, in particular, this specific kind of technology?
Yeah, I think our origin is in the port, so that's why we focus on the port-related sector. So that's oil and gas, that's offshore and maritime. But you know, we see due to the propeller and the exposure we had in the press, we get all sorts of requests actually from all like building and construction as well, because you know buildings are getting more complex. You have these nodes. It could be very interesting. We are actually working on a project to build nodes. You know, where all these connections come together, and the more complex these connections are, the tougher it is to weld them together. So if you could print them, there's a solution there. Of course, aerospace. There's a lot of companies already working on this technology with titanium, and then I think for automotive and for die repair, for instance, to make dies and molds. This is also a very interesting tool to actually repair parts. So you could repair a die. Right now they're just thrown away often. So we've been to a factory in China where they stamp these turbine blades, and after one day these dies are worn off and they're just scrapped.
Wow!
And they can be repaired, and they're trying to, but right now it's manually done. So and there are not enough welders that are so good that they can basically 3D weld layer on layer on top of each other. They're
By
so
hand,
good. They're
right.
such a steady hand. So that's a large, very huge potential there. So it's we're finding out every day new things for not only mold making, but also repair, but also making molds with this, because you could add extra cooling channels and stuff like that. So yeah, that's a nice thing about the lab. We're open, and many companies come to us and say, hey, can we look into this? And then yeah, so we have some interesting projects coming along.
So you told us about the propeller, or the propeller that you're finished with, the hook that you're finishing up.
Yeah, it should be finished this year.
What are future plans that you have? Do you have some things on the books now that you're looking to do after this, once you have the bandwidth?
That you're allowed to talk about.
Oh yeah, of course.
Yeah, so we have some ideas. I think what's also a very interesting market is the oil gas, but more actually the pump and impeller market.
Okay.
So if you have the propellers, that's about a 4 billion market, and you have the impellers,
right.
and that's a 40 billion market. So it's
that's why I said impeller.
Is that why?
That's why I said
all about the money. Okay.
Yeah, but you know, these if you then it really becomes interesting if you could combine it with predictive maintenance, for instance. So when you know a part is going to break down, for these plants, you
can start printing one.
You can already start printing one, and then you don't need the warehouse anymore. You can just reduce your warehouse at least. So those are some exciting things we are looking into right now. Yeah, and some other projects, but I think we'll
we can leave it at that.
Yeah, we can leave it at that. That's good. That's good.
So, any other technical questions that you have for him, Luke?
No, I don't think so.
Okay.
This was good.
So the last thing I wanted to ask about was, I know that you're partnered up with Autodesk. You have a lot of other great partners listed on your website.
Yeah.
If other people were interested in what they heard about today, if they wanted to get involved either with working with you or partnering with you, what would next steps be?
Well, definitely check out our website, of course, ramlab.com. Our Twitter handle, RAMLABNL, so not RAMLab, but RAMLABNL. Yeah, and if you have an idea, you know, we're always open for crazy new ideas. So just drop me a line, and we're always ready to look into it.
And we only take a small cut if it comes through the podcast.
Right,
so
right.
As a finder's fee.
Is there a referral code?
Yeah, right. As a finder's fee, just of that impeller money.
Good thinking, yeah.
Just a slice. Right?
Just a small slice. All right. Well, I think that's all that we have here. Thanks a lot for joining us today.
Thank you very much.
I think this is wrapping up our time at Accelerate 2018 for today. If you do have any questions, head over to the RAMLAB webpage or check them out on Twitter, RAMLABNL.
That's right.
All right. Well, thanks a lot, and until next time.
All right.
See you.
Thank you.